Welcome to episode 56 of FTCE Seminar, a teacher certification podcast. Today we will be applying linear, quadratic, and exponential functions to model and analyze real-world relationships. This will help you prepare for the FTCE General Knowledge Mathematics subtest. Concept 1, linear, quadratic, and exponential functions. Today's episode is all about functions and equations that describe the relationships between things. More specifically, we're focusing on linear, quadratic, and exponential functions. And, how can we even use these things in real-world scenarios? So let's get started and let's first clarify what we're even talking about. Linear functions. Imagine a straight line. That's the graph of a linear function. This function tells us how things change at a constant rate. Think about saving money. The more weeks you work, your input X. The more money you save, your output Y. The relationship is pretty straightforward. You save a fixed amount each week. This is a perfect example of a linear function in action. Next, we have a quadratic function. This function creates a U-shaped or an upside-down U-shaped curve. It's great for situations where the rate of change isn't constant. For instance, imagine throwing a ball in the air. As it goes up, Y, the distance it travels increases, positive change, but at the peak, it stops going up and starts coming down, negative change. This change in direction is captured by the quadratic function. Finally, we have the exponential function. This one creates a dramatic curve, either skyrocketing upwards or plummeting downwards. It's perfect for situations where change happens really fast. Think about a YouTube video going viral. As the number of people who watch it increases X, the number of videos viewed, Y, explodes exponentially. Now, how do we use these functions to analyze real-world stuff? Okay, fair enough. First, we can take data points from the real world. That's a good start. For example, we talked about saving money. Data for this would look like the number of weeks you worked and the amount you saved. You would actually just kind of plot these on a graph. See, we can use our knowledge to find the function that best fits the data. This best fit function becomes our model, and it allows us to explain, predict, and make data-driven decisions. Another example with our savings model is we can predict how much money you'll have saved after a certain number of weeks. See, that would be predictive. Make sense? Okay, pretty cool, right? But how exactly do functions, again, model more than money? Imagine a bakery. Yes, a bakery that sells cookies. I love cookies. The number of cookies you buy, X, affects the total cost you pay, Y. We can express this relationship with a linear function like Y equals 2X plus 3, where 2 represents the price per cookie and 3 is the fixed cost, maybe for the box and the little napkin with your cool logo on it and stuff like that. See, the function tells us how the cost changes related to the increase in the number of cookies. Just remember, linear functions are great for modeling proportional relationships where the change in one variable is constant for every change in the other. But what if the things aren't as simple as the constant change? I know, life. Good question. You always ask really good questions. This is where the quadratic functions come in. Imagine you're throwing the ball in the air. The height of the ball, Y, depends on the time it's been in the air, X. The relationship isn't constant. The ball reaches a peak and then it falls. You toss it up again, it reaches a peak and then it falls. See, quadratic functions with their curved shapes can model these non-proportional relationships, meaning the curve of the function reflects the changing height of the ball. Just remember that quadratic functions are useful for modeling things with a peak or a dip, like projectile motion or profit depending on production costs. Next question, what about things that increase or decrease rapidly, like bacteria cultures or social media followers? Yeah, that's pretty funny. That's kind of a weird example there. Yeah. Okay. But it was a good question. Enter exponential functions. These functions involve variables and their exponents, leading to dramatic increases or decreases. They're perfect for modeling situations where change accelerates over time, meaning the function shape shows how things grow or shrink exponentially. Think of it this way. Exponential functions are crucial in many fields, from finance, like modeling compound interest, to biology, like tracking population growth. The key is to identify the type of relationship you're modeling and ask yourself this: is it constant change? If it's constant change, think linear. Is it a peak or a dip? If it's a peak or a dip, think quadratic. Or if it's rapid increase or decreases, think exponential. So by choosing the right function, we can mathematically interpret and analyze real world situations. Exactly. These functions are like tools in our mathematical toolbox. We can use them to understand data trends, make predictions, and even explain pretty much anything. For more practice with math strategies, visit ftceseminar.com to study for the test. The important thing is to start studying today so you can pass your teacher certification exam. Well, what are you waiting for? Check us out on YouTube at FTCE Seminar and start studying today. This podcast was recorded at the Pickens Multimedia Studio at the University of West Florida. This podcast is listener supported and contributions can be made via the listener support link on Spotify, or you can buy me a coffee at FTCE Seminar. This is your host, Mercedes Musto. Join me again on FTCE Seminar's Teacher Certification Podcast so you can pass the FTCE.